So today we're going to talk about solving systems of inequalities. Now for a lot of you this will feel pretty much like review. That's great. We've done a lot of new things in chapter 9. It's alright if something feels like review. The second problem of the notes is going to feel a little bit more challenging. So feel free to skip ahead, rewind, go back, put on closed captions, anything like that. Take this opportunity, if you haven't already, to set up the notes for yourself or print them out if that's what you're used to. So let's get started. So this first one, we've just got two linear inequalities, right? We don't have any exponents or anything here. And this is the part that will definitely feel like review, hopefully, to most of you. Because what we're going to do is we're going to graph these. And if we're talking about lines, we're going to want to graph in slope-intercept form. So that first one, we're just going to subtract the x over, and so we end up with y is greater than or equal to negative x plus 1 as our slope-intercept form. For the second equation, we're going to subtract over the 2x, but then we're going to have negative y here. And when we get rid of that negative, we're going to make that positive, but the sign is going to flip. If you remember that about inequalities. So all the negatives are going to change, and then the sign is going to turn into a greater than sign. And our slope-intercept form for that line is then y is greater than 2x minus 3. So once they're in slope-intercept form, we're going to graph. And if you remember correctly, when it has greater than or equal to or less than or equal to, that line is going to be different than if it's just like this. And that's what we ask ourselves the question, if that boundary is open or if it's closed. If it's an open boundary, that means that we're using either the less than sign or the greater than sign. If it's closed, it's less than or equal to or greater than or equal to. The open boundary is a dotted line, like this, and then the closed boundary would be a solid line. So in this case, our first line is going to be solid. We're going to put in the y-intercept and then a negative slope going down, -1, and we're going to make sure that we're drawing a nice solid line all the way down. It's nice to do it all the way across the entire graph for inequalities, even if we wouldn't necessarily do it for our every line. Then when we graph our second one, going through at -3 and then up 2 over 1, when we draw that line across everything, we're going to make sure that's dotted because that's an open boundary. So that's the first step where it's different. The next one is when it comes to shading. With lines, we either shade above the line or below the line. And the inequality symbol tells us which. In this case, for both of these, the y is the biggest one. Right here, y is greater. So that means on the axis, we're talking about above the line because our y-axis is pointing upward. So if we look at both these lines, you can shade them separately. For the first one, we're talking about this area above the line all the way across. And then for the second one, we're talking about above the line here. And then the solution you can see is this area where they both intercept. See how we've got green and red, but only in this triangular shape? That is the actual solution. That's where you want to take your pencil or your pen and shade that in more clearly. If you're someone who likes to erase, that's fine. This is all I would expect you to do. Just make it very clear that you can demonstrate, oh, it's the overlap where it's both green and red in this case. But for neatness' sake, you can erase, but I'm just fine with you leaving it like this. Hopefully the linear ones feel familiar. If this doesn't feel familiar, please schedule in some time to chat on Zoom because I am expecting that this should feel pretty similar to what you've done in the past. The way that we're going to add a little bit of challenge to this is not everything is going to be linear. So what you'll want to do is be able to identify the types of graphs we're looking at and graph all of them. And the main different type of graph that you're going to see here, right, is this shape here. And what some of you are going to remember, and some of you will want that review, is that if you have an x squared plus y squared, and that's equal or less than or greater than to r squared, is that this is a circle centered at the origin with a radius of r. So in the case of this first equation, we've got x squared plus y squared is less than 25. So what this says is that it's a circle with radius 5 centered at the origin. And so when we graph our first part, it's an open boundary here. So what I do when I graph a circle centered at the origin is if this is its center here, its radius is going to be 5 out in every direction. So there's one there, a point here. So I draw the points on the axes, like so. And then this one will be dotted, which makes it even more challenging than it might be. But I'm going to do my best to draw in a nice circle, hitting all those points. Try not to go beyond. That's just fine. Now, the shading here is also a little tricky because what this is saying is that this side is the circle and then here's the radius. So in this case, we're talking about these points, the x and y that are less than the radius. So if your x and y is less than the radius, that's talking about the inside of the circle. So with our first graph, we're talking about this shaded region inside the circle. Now to find where it overlaps with the other one, here we've got x squared minus y is greater than 0. I'm going to get y by itself, add it to the other side, so we get x squared is greater than or equal to y, which is a nice parabola, no transformations or anything, so it's going through the origin. Then here, like so, on both sides, nice solid line. Here, because it is a closed boundary, and then the y is smaller, so that means that we're shading below this parabola, like so. And so then the overlap is the inside of the circle and under the parabola, which is this kind of odd moon-esque shape here, where the two sections are overlapping. So if you want to practice with your linear ones first, I think that that's good, but do make sure that you can also do these problems with circles and with parabolas. Leave any questions you have in the comments, or you can contact me on Zoom or Google Classroom or email.